Okay guys, let's look at another example for the eigenvalues and eigenvectors. So look here, we have given matrix T is 1, 0, 2, negative 1, 4, 3 and 2, 0, 1. So show that the eigenvalues of T are lambda 1 equals to negative 1, lambda 2 is 3 and lambda 3 is 4. And then secondly, we want to find the normal eigenvector. So remember, we have here is normal eigenvector corresponding to the smallest eigenvalue of T. Alright, so let's look at the solution. Okay, to find the eigenvalues, we will use the determinant E minus lambda I equals to 0. Alright, so firstly, your determinant E minus lambda I, it will be 1 minus lambda, 4 minus lambda and 1 minus lambda. So it is easier to write in your main diagonal first before you can proceed with the next entry. Okay, 0, 2 here, and we have negative 1 and 3 here, 2 and 0 here, and the determinant is equals to 0. Okay, so to find the determinant, you can also use the Zariski method. Okay, so to use the Zariski method, we will write the first two columns. Okay, that means we have here 1 minus lambda, this one negative 1, this one is 2, 0, 4 minus lambda and 0. Okay, so now let's solve for the determinant. So we will have here the first one is this one. Okay, that is we have 1 minus lambda times 4 minus lambda times 1 minus lambda. Okay, next we have this one. Okay, since we have 0 there, 0 times 3 times 2, so we just put plus 0, and then plus the third one, we have this one, and still we have 2 times negative 1 times 0, we have 0, and then minus with, so we have here is this one, so 2 times 4. Okay, we have 2 times 4 minus, 2 times 4 minus lambda times 2. Okay, and then plus with, and we have here is also 0. Okay, we have is also 0, and another one is also 0. Plus 0 plus 0 equals to 0. Okay, so next we will simplify. Okay, to simplify, we just expand all the bracket. We have 1 minus lambda, so this one, let's say if you expand, you will get 4 minus, okay, minus 4 lambda minus 1 lambda, you will get minus 5 lambda plus lambda square, and then minus, for this one you will get 4 times, okay, 4 times 4 minus lambda equals to 0, and then continue, expand, you will get it is 4 minus 5 lambda plus lambda square minus 4 lambda plus 5 lambda square minus lambda cubic, okay, minus 16 and plus 4 lambda equals to 0. Okay, then we will simplify, you will get it is minus lambda cube and then plus 6 lambda square, right, and then we have minus 5 minus 4 is minus 9 plus 4, so minus 5 lambda, and then we have for numbers 4 minus 16, it is negative 12 equals to 0. Okay, so next you can simplify just using calculator. So basically, if you want to use calculator, please make sure the coefficient of your lambda cubic is positive. So you will write as lambda cube minus 6 lambda square plus 5 lambda plus 12 equals to 0. So you can just use calculator. Okay, and you will get the answer will be lambda 1 is negative 1, lambda 2 is 3, and lambda 3 is 4. Okay, so this is we have shown the answer for the first question. Alright. Okay, next we want to find the normal eigenvector corresponding to the smallest eigenvalue of t. So your smallest eigenvalue now is lambda equals to -1. Alright, so next we will substitute in the formula of E minus lambda Ix equals to 0. So you will get the matrix equation is, so 2, 4 plus 1 is 5 and 1 plus 1 is 2 here. Alright, so remember it is easier to write your main diagonal first. Okay, and then we have this one. Okay, alright, next we will solve by using augmented matrix. Alright, so your augmented matrix will be 2, 0, 2 slash 0, -1, 5, 3, 0, 2, 0, 2, 0. Okay, continue with the ERO. Okay, so this is your row echelon form. Alright, so we have the leading variables here is, so your leading variable is x1 and x2. Okay, and your free variable is x3. Alright, so let's assume that assign a parameter in your free variable. So we have x3 is t, where your t is any real number. And then for row 2, you will have x2 plus 4 over 5 x3 equals to 0. So you will have x2 is -4 over 5 x3, which means you will get your x2 is -4 over 5t. Right, next for row 1, we will have x1 plus x3 equals to 0. So you have x1 is -x3. Okay, so which means we will get negative of t. Alright, so what will be your eigenvector? Okay, so now the eigenvector will be, okay, let's say we use x, so it will be -t, -4 over 5t, and t, and we can write as t, -1, -4 over 5, and 1. Alright, okay, so please remember the question asked you to find the normal eigenvector. Okay, so the normal eigenvector, to find the normal eigenvector you need to find the magnitude. So the formula of normal eigenvector, okay, it is u equals to x divided by magnitude x, or you can also write as 1 over magnitude x times matrix x. Okay, so let's find the magnitude. Okay, so magnitude x here will be the square root of, okay, so -t square plus -4 over 5t square plus t square, and we will get, okay, your magnitude x is square root 66 over 5t. Okay, now substitute in your formula of the normal eigenvector. So we have here u is x divided by magnitude x, so we will get it is t, okay, t -1, -4 over 5, 1 divide by, so your magnitude x is square root 66 over 5t. Then when you simplify, okay, you can cancel off your t, so it will be, now it is 5 over square root 66, -1, -4 over 5, and 1. So this is the normal eigenvector.